Ever pondered the question, what is everything made of? Well, in the early 19th century, an English chemist named John Dalton proposed a groundbreaking answer. He suggested that all matter, from the air we breathe to the stars in the sky, is composed of tiny, indivisible particles called atoms. This sparked a revolution in scientific thought and laid the foundation for modern chemistry. Dalton's first postulate, that all matter is made of atoms, was quite a departure from the then prevailing belief that matter could be infinitely divided. Picture slicing an apple in half, then in half again and again. According to Dalton, you'd eventually reach a point where you couldn't slice any further. That ultimate unsliceable piece would be an atom. His second postulate stated that atoms of a certain element are identical. Just as every grain of rice in a bag is virtually the same, every atom of a specific element, say gold, is identical in size, mass, and chemical properties. This means all gold atoms are exactly alike. However, they are fundamentally different from atoms of another element, like hydrogen, which leads us to Dalton's third postulate. He proposed that atoms of different elements are distinct. They have different sizes, masses, and chemical properties. This is why hydrogen, the lightest element, is vastly different from gold, one of the heaviest. It's this diversity among atoms that gives rise to the vast array of materials we see in the world around us. The fourth postulate Dalton proposed was that atoms are indestructible, at least in chemical reactions. A chemical reaction, according to him, is merely a rearrangement of atoms. Picture a deck of cards. You can shuffle them any number of ways, but the cards themselves don't change. Similarly, atoms can't be created or destroyed during a chemical reaction. They merely reshuffled to form new substances. The fifth and final postulate of Dalton's atomic theory is that atoms combine in simple ratios to form compounds. Just like a recipe calls for specific proportions of ingredients, atoms combine in specific whole number ratios to form compounds. For instance, water is always formed by two hydrogen atoms combining with one oxygen atom, hence the chemical formula H2O. While later scientific discoveries have shown that atoms are not truly indivisible, as they contain subatomic particles like protons, neutrons, and electrons, Dalton's atomic theory remains a cornerstone of modern chemistry. It provides a robust framework for understanding the behavior of matter and the interactions between different elements. In essence, Dalton's atomic theory has allowed us to comprehend the microscopic building blocks that make up our vast, diverse universe. And that, my friends, is the beauty and power of chemistry.